Grab a seat, thanks guys. Yes. Wonderful. Okay guys, let's get started. Thank you. So we got, first of all, thanks to Fakile for coming and calling me. I was sitting there lumming with Mr. Esau drinking coffee and I thought there was going to be a break.
You're lumming with Mr. Esau.
Whoa! And I thought we were going to have a break. Okay. But our time is very precious, so let me tell you exactly what we're going to do. So Nelly, you and Anneli who missed the test, and Adna will write it as well. We'll give you the test in the second period I see you, the organic test, and then you can write the physics test from then onwards through break. Okay, it won't take you that long. I will give you different values to what I gave them because I've already shared the, well, let's not say anything more. Okay, so we've got quite a lot to do today. This period we're going to do organic chemistry, and then next period we're going to write the test, finish the practical, and those people, and finish handing in homework. You see, those last two physics questions I gave you, okay, those have to be done before you leave as well. Okay. If we could just keep it quiet as well for recording, but it's also, you're going to learn, I'm going to give you a whole organics lesson now. You're going to have to listen, and then I'm going to just write the highlight notes, and you're going to have to make your own notes. Okay, so remember, we're back to memory. I'm going to put all the main points here. I think those people with a second language, not English, first language, not English, obviously you would struggle just a little bit more, but then your memory may be fantastic. So everyone's going to manage. Okay, are we happy? Let's just see how we go. So we're going to introduce you to some more organic chemistry. Now you have met the first four families, the alkanes, which the alcohols, the carboxylic acids, and the esters. We gave you a sheet on the back of this one that is more or less what I'm going to be dealing with today. So if you've got this sheet, if you could turn to the back, this may help you. Now, we're going to be introducing you to the next, have you not got a copy?
You have my paper.
Oh, I've got your copy. We're going to be introducing you to 5 or 6 more families, and we're going to start talking about their properties. Now, I don't know about you, but I cannot write and listen at the same time, so maybe it's a good idea if you guys listen and then write afterwards. But maybe you're more talented than you could write and listen at the same time. I couldn't. Okay. Let's just start with the family of alkanes. Who can tell me anything about their properties? Anything you know about their properties? Clear? Methane, ethane, propane, butane. What can you tell me about it? They end with A and E, but now their physical properties. Do you know anything about methane? They got 4 hydrogen and 1 carbon. What? Is it a liquid, a solid, or a gas? That's the sort of thing I'm talking about. Okay, it's a gas. Now, this is what we're talking about today. Why is it a gas? Anyone know anything about methane? It's in the news. Anyone know in connection with what? Methane. You've heard of global warming? I'll give you a hint. Methane? Heard anything in connection with global warming? And it's not a CFC. It's just methane. But have you heard of greenhouse gas?
Yes.
What does greenhouse gas do? Attracts heat. And methane is like dozens of times more potent than CO2 at trapping heat. Happy with that? So methane is a greenhouse gas. Now, why is it a gas? You have also met the alcohols. You use them. Methanol. Let's all say it together. Methanol, ethanol, propanol, butanol, pentanol, hexanol, heptanol, octanol. So you're going to be tested on that next period. Well done. You've used them. They were all solids, liquids, or gases.
Liquids.
Like methanol is methylated spirits, right? Drink it and you go blind. You don't get drunk, you just go blind, but you do get drunk before you go blind. So they all end in OH. In the old days, the arties, burgies used to pour meths through bread, white bread. It used to filter out some of the meths, then they drink it, go blind, but get drunk first. Terrible idea to perform science, chemistry experiments on yourself. I've never taken a single drug. I don't even know what marijuana smells like or has an effect on you. I don't want to be a guinea pig for chemistry experiments. You know, this brain here is like, you guys might have lots of it to spare. I've got just so much and I'm hanging on to it. So you brilliant guys, you can blow half of it and you might still survive. Me, I blow half of it, I won't find my way home. Okay, so chemistry experiments. This is methanols. So all the alcohols are liquids. When we say they're liquids, what do we mean? They're liquids at room temperature, which is about 23 degrees centigrade today. There is a specific room temperature. Now, geniuses, you won't know the answer, but I just want to test you anyway. Why is that a gas and that a liquid?
So because why?
Because why?
Because it's extra oxygen and alcohol.
Do you agree that the only difference between that and that is the extra oxygen? Now, oxygen's got an atomic number of 8 and an atomic mass of 16 if you look on the periodic table. It's quite a heavy element. Do you think it's the weight of the oxygen that makes it a liquid, or do you think there's something else? This is a trick question.
Something else.
So I think it's
Carbon has a value of 7, atomic mass 14. It's lighter. Hydrogen's got an atomic mass and an atomic number of 1. So hydrogen's a very light little atom. Do you think it's the weight that makes it a liquid and a gas? Who says it's the weight that makes it a liquid and a gas?
Is it the intermolecular forces?
Well, we could almost test that experiment. Do you know ethane, CC, and the hydrogen? That's ethane. Is that a gas?
yes. Yes.
Ethane is a gas at room temperature. Then we come to propane, which is used. Anyone know what propane is used for?
Cough medicine.
So use it for external uses.
Medicine.
Propane is used in, like the gas that comes to, any of you cook with gas?
Yes.
That cooking gas is propane.
But the blue
Is propane as a gas or a liquid at room temperature?
Yes.
So it's a gas at room temperature. If they compress it and put it in a bottle, that makes it a liquid. But the moment you release the pressure, it becomes a gas. So it's actually a gas at room temperature. Then you got your cigarette lighter, which is what? Butane. Now, you see butane has got how many carbons? 4. Each with a weight of 14. 4 14s is about 60. Actually, 56. Right? Am I right in my math?
414.
4 14s? 54.
No, 4.
No. 14
So is it right?
40 and 4 4s is 60,
That's
56.
Yes,
56.
you're
Okay.
Your brain is working well.
Thank you. I'll find my way home tonight. Still. One day I'll just won't and then I won't be back. Okay. Now look at 56 plus how many hydrogens? 3, 4, 5, 6, 7, 8, 9, 10. So it's 66 is its weight, but it's still a gas at room temperature. If we let it lie there, it all just evaporate. Whereas look at this one, it's a liquid and it only has a mass of 16 plus 14 is 30. 1, 32, 33, 34. And that's a liquid. Makes sense? It's not the weight. It's something else. What is it? Now, it's this thing called intermolecular forces. And we also have intramolecular forces. Now, we're talking about intermolecular forces. Which one's on the outside and which is on the inside? So, intra school sports is like blue house plays, greenhouse, that's inside the school. Intra is inside. Inter schools is between. So we are talking here about intermolecular forces, between molecule forces. Do you know what the bonds are called, which are called the intramolecular forces that hold this together? Do you remember what kind of bonds these are all? Those are all what kind of bonds?
Hydrogen bond. Hydrogen.
Try again. I'll give you, it's not ionic, but it's
Covalent.
covalent. So what are the intramolecular forces? They are what type of bond? Covalent bond. Sunil, does that make sense to you? So now we're talking about bonds that are outside. How will I illustrate this? Okay, it's like being sticky. Every molecule is slightly sticky. I'm trying to make this a bit stickier, but this Pritz I bought from the crazy shop, it's not very sticky. I meant to bring sticky tape, but I haven't got it. Okay, so do you get the idea? We're talking about intermolecular forces. Now, if I had a piece of sticky tape, anyone got a piece of sticky tape? Let's just see if your Prit works better. Okay, so there's the, thank you, intermolecular force, sticking the paper to the board. Or paper to another paper. So these are the molecules. So here's one methane, here's another methane, we stick them together. Now it's two pieces of paper, but they're held together by what type of forces? Is it?
Intramolecular forces.
Intermolecular forces.
Intra.
What is the paper held together by? Intramolecular forces that holds the paper together. Which forces are stronger, the inter or the intra? Which is stronger? Does the paper stick together better than the two papers together? I know this is confusing because those names confuse me. Okay, we're
So
talking.
inter is between right and intra is outside.
You see, the paper is strong. What type of force is that? Intra. And what is it? Covalent bonds. Everybody say this is the covalent bond forming the intramolecular forces. That's it. And then molecules can also stick themselves together with intermolecular forces. Now, watch this. If they can be shaken together, apart, at room temperature, I think I'm going to need some more of your crit, if you don't mind. Thank you. Because our intermolecular force is falling apart here. Super. Just remind me, because I might have a kleptomaniac moment. Okay, now watch this. This is room temperature. If I can shake it apart at room temperature, now all molecules shake like this. Did you know that? We call it, all molecules have kinetic energy. If the kinetic energy at room temperature can shake it apart, then it's a gas. If at room temperature the intermolecular forces are so weak that it can shake it apart, then it's a gas. However, if at room temperature the forces are strong enough to hold it together, then it becomes a liquid or a solid.
So now tell the difference between liquid and solid.
A liquid and a solid. If
Solid is particles
If I offer you a glass of something that's a liquid, it pours out, right? It fills the bottom of the glass.
I know that, but I mean in this context.
In this context, how would you know if it's a solid or a liquid?
Yes.
Okay, so this is the way it works. At the very lowest temperature, virtually everything is a solid, because at the lowest temperature, the kinetic energy is so weak that the forces, although they may be terribly weak, hold everything together as a solid, right? We're talking about minus 273 degrees centigrade. That's the coldest thing in the universe. It doesn't get colder than minus 273. It's called absolute zero. At absolute zero, no shaking occurs. After 1 degree above absolute zero, things start to shake. And at room temperature, things are really shaking. Happy with that? And so some things get shaken apart, and if they get shaken apart, they are gases. Everyone happy? Okay. Now, what's the difference between a liquid and a gas? Well, liquids, although they are technically somewhat apart, they never quite leave each other. They slip past each other, but they stay close and in contact with each other, and they will always fill the bottom of the container. That's a liquid. So the intermolecular forces of liquids are, help me out here. The intermolecular forces of liquids are stronger than gases, but weaker than solids. Let's say that, everybody. Intermolecular forces of liquids are stronger than gases, but weaker than solids. Now, you see, solids are stuck together. It takes a lot to shake a solid apart because of their intermolecular forces. Now, I worked it out. This is the Stephen Thomas system of working out intermolecular forces. It's not part of the syllabus, but it really helps me. Now listen to this. The moment you add an oxygen, its stickiness increases by 10. 10 compared to what? Each hydrogen has got a stickiness of 1. So what is the total stickiness of methane? Let's count. 1, 2, 3, 4. So here we have developed a scale of stickiness. Methane is 4. We don't count the carbon because it sits in the middle. It's protected from sticking against anything else. You see what I'm saying? Does that make sense?
Yes, sir.
Okay, makes sense. So take it. This has got a stickiness of 4. What do you think is the stickiness of ethane? What's the stickiness of ethane? 6. Is it more sticky than methane? Therefore, it's going to be closer to being a liquid, but it's still a gas. Take it. Now, what is butane stickiness? What's butane stickiness? 10. And butane's just about becoming a liquid, but it's still a gas at room temperature. It's what you have in your cigarette lighter. Okay, but it's only slightly under pressure in your lighter. So can we say that 10 is just about a liquid? Now let's go to here. I said the moment you have an oxygen, you've got 10 already. 11, 12, 13, 14, as opposed to 10. So 14, around about 14, you're a liquid. Does that make kind of some sort of sense?
Yes, sir.
All the alcohols are liquids because they all have a stickiness above about 12. About 12 is a liquid. Why do I say that? Because look at this common thing here, H2O. It looks like this. What do you think its stickiness is? It's got oxygen, which is 10, and each hydrogen is 1, so that's about 12. And that's why water is a liquid. It's quite sticky. Are you happy with that? Now, with that in mind, let's go to our carboxylic acids. Now we come to here, C double bond O, OH. Sorry. That is, what is it called? Methanoic acid. Let's work out its stickiness. Now, just listen to this. This is the last real complication. So my coffee's getting cold. Okay, this is the last complication. When it's got a double bond, that's got a stickiness of about 4. I'll tell you why. When it's OH, it's got a stickiness, that oxygen's got a stickiness of 10 and the hydrogen about 1. Why? Why is it that this is an oxygen double bond has only got a stickiness of about 4? And then what's the stickiness of those two each? About 1. So what's the total stickiness of this? 4, 5, 6, 7, 17. Sorry? Oh, thank you. So 4, 5, 6, 16. So is it going to be a liquid at room temperature? It's going to be above 12 or so it's going to be a liquid. Was your methanoic acid a liquid? Did we have methanoic acid? I'm not sure. But it would have been a liquid.
So yes.
And then all the others are longer, so they're going to have. Make sense?
Sir, but why is it 4?
Okay. Are you guys, your brain's not fried yet?
No, sir.
Okay, good. I know. The brain's got infinite. Okay, let's give you the last bit on this. If you go to the periodic table, or if you go to that sheet that I gave you, it has a number, not on this table, but on the one I gave you. And it's called the electronegativity. Did I put it on here? I meant to. Yeah, there it is. 2.5 for carbon, 2.1 for hydrogen, and for oxygen 3.5, and for fluorine 4. Just see if you can locate those numbers they on the side there. Who can see them? Okay.
Yes, sir.
Okay, so let's just deal with this.
So one oxygen one is stable, but our oxygen one is.
Yeah, okay, let's have a look at this. Electronegativity is this. I know I'm talking for a long time. Oxygen's got 3.5, hydrogen's got an electronegativity of 2.1. What does that mean? Electronegativity means how much, if this is a covalent bond, it means I share a pair of electrons. There's the shared pair of electrons. Do you remember that from 11 and 10?
Yes,
Covalent bonds?
yes.
But say I've got an inheritance and I share it with my brother. My brother can get 80% of the inheritance. I could get a share of 20. We still shared it, but he got 80 out of 20 because my father hated me and he loved my brother. Okay, you see my point. We could share, but not share equally. Make sense? So what happens is oxygen shares 3.5 times more than hydrogen's 2.1. So the electrons are closer to the oxygen. Although they go around both of them, they spend more time around the oxygen. So what does it create? It makes the oxygen negative and it makes the hydrogen slightly positive. So now you've got a negative and a positive. When you've got negative and a positive, you've got a magnet. You've got a north and a south. You've got positive attracts negative. So what happens is this. Again, let me do it with a simple molecule like water. Where are the electrons going to spend most of their time? Around the oxygen or the hydrogen? Oxygen. So here is what it's going to look like. Here's the electrons, and they spend only a tiny bit of time around the hydrogen. So this becomes negative, and this side becomes positive. Because the electrons are shared, but not shared equally in a covalent bond there. So if we take another water molecule, and we stick it like this, this side is positive, that side's negative. Now it creates this force called a hydrogen bond. And that hydrogen bond is worth 10 on the stickiness scale.
It's always worth 10.
It's worth 10 on the, it actually goes from 10 to about 30 or 40 or more. It just depends. I know you don't like it depends, but it's not an exact science. Okay, so why is OH so important? Because this OH forms a hydrogen bond. And a hydrogen bond is plus 10. Now here, do you see a hydrogen that it can form a bond with? No. So we have oxygen, which is 3.5 on the electronegativity scale, sharing with carbon, which is 2.5. And what it means is the oxygen just steals the electrons a little bit. So it's not as big a stickiness created because there's no hydrogen bond. It just creates, this means that there's a slight negative there. So, and there's a slight positive there. Slight positive, slight negative. We say in science delta negative. Here we say delta positive. Slightly positive, slightly negative. That doesn't want to stick very well, that's slightly. But if you've got a hydrogen bond, that's very sticky. And therefore, anything with a hydrogen bond will stick to something else with a hydrogen bond. All happy? Slightly, have I introduced you slightly to it? Slightly. So now, you know how to work out if something's a liquid or a gas at room temperature. If its stickiness is below about 12, it's going to be a gas. Sure. And is there any specific question that you want to go over? Of this? Anything in particular? Or shall I just try in 2 minutes to give you the everything I've said?
Yes.
Okay, let's try it again. We get intramolecular forces called covalent bond. We're not talking about them. Then between molecules, we get intermolecular forces. Now, depending on how strong those intermolecular forces are, it will turn the substance into a solid, a liquid, or a gas. The things with the strongest intermolecular forces become solids at room temperature. Things with slightly less intermolecular forces become liquids, and those that can be easily shaken apart at room temperature become gases. How do we work out the intermolecular force? Don't do this in the exam because this is my system that I worked out by myself, but it kind of works. Just looking at the boiling points of different liquids, this is the system I worked out. I worked out that if you count each, not the inside carbons, just what's around the carbons, which is the outside of the molecule, each hydrogen has got a stickiness or an intermolecular force of 1. Its scientific name is called van der Waals dispersion or London forces. I don't know if you've heard of it.
No.
But that's its technical term. This has got a van der Waals dispersion or London force, and it's approximately 1. 1 what? Who knows? But it's 1 compared to OH. OH has got not a van der Waals London dispersion force, it's got a hydrogen bond worth 10 to 40 times more than the previous one. And then lastly, if you go to the carboxylic acids, they've got a double bonded oxygen. It forms what we call a dipole, where the dipole is the oxygen slightly negative, this side becomes slightly positive, there, delta negative, slightly negative, delta positive, slightly positive, but it's only got a stickiness of about 4, which is less than hydrogen, but more than van der Waals dispersion or London forces. Did that summarize it for you? Any questions? All happy? Okay, are we ready to write our test?
Yes, sir.
Great. Okay, could you just spread out so you can't see each other? There's a whole room we can spread out to.